Acids. The word acid comes from the Latin word acidus, which means sour, which is the characteristic property of all acids. The sour taste of many substances in our food is due to the acids present in them. For example, in vinegar, acetic acid is present. In lime and citrus juices, citric acid is present. In tamarind, tartaric acid is present. Similarly, in sour milk, lactic acid is present. In apple juice, malic acid is present. And in sugar cane, glycolic acid is present. Acids can be classified as strong acids and weak acids. Strong acids are hydrochloric acid, sulfuric acid, nitric acid, etc. Weak acids are acetic acid, citric acid, tartaric acid, etc. Properties of acids. All acids are sour in taste. All acids turn blue litmus paper red. Acids are corrosive in nature and can cause serious burn injuries on skin. All acids contain hydrogen. For example, HCl, H2SO4 and HNO3. Sulfuric acid reacts with carbonates to release carbon dioxide gas, and due to this property of acids, they are used in fire extinguishers. Most acids liberate hydrogen and produce salts when they react with metals. Acids have a pungent odor. Fumes should never be smelt directly or inhaled. They should be fanned towards the nostrils gently. Uses of acids. Acetic acid is used as preservatives. Sulfuric acid and nitric acid are used in the manufacture of dyes, paints, fertilizers, drugs, and explosives. Sulfuric acid is used in the automobile industry as a dehydrating agent in refining of petroleum and in inverter batteries. Hydrochloric acid is used for purification of salts as a laboratory reagent and to make aqua regia to dissolve gold and silver. Carbonic acid is used in soft drinks and tartaric acid is used in manufacture of baking soda. The hydroxides of metals are called bases. For example, sodium hydroxide, potassium hydroxide, calcium hydroxide, etc. are bases. Properties of bases. Bases are soapy to touch and bitter in taste. Bases turn red litmus blue and neutralize acids to form salts and water. For example, if you add phenolphthalein indicator to the dilute sodium hydroxide solution, it changes to pink, that is, the solution is basic. Add dilute hydrochloric acid to it. After some time, the solution becomes colorless due to neutralization reaction. Bases are relatively less soluble in water than acids, but some bases such as sodium hydroxide, potassium hydroxide, and calcium hydroxide are soluble in water. Bases are colorless and odorless liquids. Exception: ammonia. Bases which are soluble in water are called alkalis. For example, potassium hydroxide, sodium hydroxide, and calcium hydroxide. Since all bases are not soluble in water, we can say all alkalis are bases, but all bases are not alkalis. Uses of bases. A base such as sodium hydroxide is used in the manufacture of soap. It is also used in petroleum refining, in making of paper, pulp, textile, industrial cleaners, and medicines. Calcium hydroxide is used in the manufacture of bleaching powder and fungicides, as dressing material, as antidote in food poisoning, and as a cleaning agent for purifying water. It is also used as a building material. Farmers use it to neutralize the effect of acid rain. Ammonium hydroxide is used as an ink remover and a remover of grease from glass, etc. Potassium hydroxide is used in alkaline batteries. Magnesium hydroxide is used as an antacid. Salts. There are three types of salts such as acidic, basic, and neutral salts. These salts are obtained by the neutralization of acids and bases. For example, when hydrochloric acid is added to sodium hydroxide solution, they combine with each other to form a salt and water. This reaction shows neutralization reaction. Neutralization in everyday life. Indigestion. Hydrochloric acid is present in our stomach. It helps in the digestion of food. Excessive hydrochloric acid in the stomach causes a burning sensation and acidity. Antacids such as milk of magnesia containing magnesium hydroxide provides relief from acidity. Magnesium hydroxide neutralizes the excess acid present in the stomach. Ant sting. Formic acid is present in the sting of an ant. If an ant bites, it injects the acidic liquid into the skin. The pain due to the acidic ant sting can be neutralized by rubbing moist baking soda or calamine solution, which act as bases. Soil treatment. Let us do an activity to neutralize acidic soil. Take a sample of acidic soil. Put it in water. Now check its pH using a pH paper. It shows that the solution is acidic. Add quicklime or slaked lime to the solution. Now check the pH of the solution. It shows that the solution is neutral because quicklime or slaked lime acts as a base and it neutralizes the acid present in the soil. Factory wastes. When factory wastes are disposed of in water bodies, the acid present in them kills the fish and other organisms living in the water bodies. So, the factory wastes must be neutralized by adding basic substances before disposing them off in the water bodies. Indicators. An indicator is a substance that changes color when brought in contact with an acid or a base. It is dangerous to touch, smell, or taste the different chemical reagents available in the laboratory. Hence, it is much safer and better to use an indicator. Natural indicators. A number of things which we find around us can be used as natural indicators. Synthetic indicators. There are some synthetic indicators which are used in lab to test acidic or basic behavior of a solution. Litmus solution. It is a purple dye extracted from the lichen plant. It is commonly used as an indicator in laboratories. If you add litmus solution to the acids, it changes to red, and to bases, it changes to blue in color. Natural indicator. Take lemon juice in a test tube and mix it with water. Put a drop of above solution on a strip of red litmus paper with the help of a dropper. You will observe that there is no change in the color of the litmus paper. Now put a drop of this solution on blue litmus paper. The blue litmus paper turns red. It indicates that the solution is acidic because in acidic solution, red litmus paper does not change the color while blue litmus paper turns red. Repeat the same activity with tap water, detergent solution, aerated drink, soap solution, shampoo, common salt solution, sugar solution, vinegar, baking soda solution, milk of magnesia, washing soda solution, lime water, and observe the changes. Turmeric solution. Turmeric indicator solution is prepared by mixing turmeric powder with propyl alcohol. It gives pink color in acidic solution and reddish brown in basic solution. Natural indicator. Turmeric solution. Take some quantity of turmeric powder in a beaker. Make the paste by adding some water. Now make turmeric paper by depositing the turmeric paste on a filter paper and drying it. Cut thin strips of the yellow paper obtained. Put a drop of soap solution on the strip of turmeric paper. You will observe that the turmeric paper turns reddish brown in color. This activity shows that the turmeric paper acts as an indicator and indicates the basic nature of soap solution. China rose. It is prepared by mixing China rose petals with warm water. The solution becomes colored after some time. It gives dark pink in acidic solution and green in basic solution. Natural indicator. China rose. Take some China rose petals in a beaker. Add some warm water to it. Keep the mixture for some time till the water becomes colored. Take some substances such as shampoo solution, soda water, lemon juice, sodium hydrogen carbonate solution, vinegar, sugar solution, and common salt solution. Add 5 drops of China rose indicator to each of the solutions and observe the changes in color. You will observe that shampoo solution, soda water, lemon juice, and vinegar turn dark pink in color. Sodium hydrogen carbonate solution turns green, while sugar solution and common salt solution do not change color. Red cabbage juice. It is prepared by boiling red cabbage. It is an acid or base indicator. It turns red in acid and in base it turns yellow in color. Blackcurrant juice. Blackcurrant juice is extracted from blackcurrant. When you add blackcurrant juice to an acidic solution, it changes to red, and in a base it gives blue or violet color. Beetroot juice. Beetroot juice is extracted from beetroot. It turns red in acid and yellow in base. Effects of natural indicators on acids and bases. A, B, C, D, etc. Put hydrochloric acid in test tube A, sulfuric acid in test tube B, nitric acid in test tube C, acetic acid in test tube D, sodium hydroxide in test tube E, ammonium hydroxide in test tube F, and calcium hydroxide in test tube G. Take indicators such as red litmus solution, turmeric solution, and China rose solution. First, add litmus solution in each of the test tubes and observe the change in color. Now, repeat this activity with turmeric solution and China rose and observe the color change. Phenolphthalein. It is a chemical compound having chemical formula C20H14O4. It gives no color in acidic solution, but in basic solution gives pink color. Neutralization reaction. Take a 100 milliliter beaker and add 1/4 part of hydrochloric acid to it. Now, take phenolphthalein solution and add 2 to 3 drops of it to the beaker containing hydrochloric acid and shake the solution. Observe the change in color. You will observe that there is no change in the color. Now, add a drop of sodium hydroxide solution with the help of a dropper and stir the beaker gently. Observe the color again. You will observe that there is no color change again. Continue adding sodium hydroxide solution drop by drop while stirring till the pink color begins to appear. Now add one more drop of dilute hydrochloric acid to the beaker. You will observe that the solution again becomes colorless. Add 1 drop of sodium hydroxide solution again. You will observe that the solution again becomes pink in color. This activity shows that when the solution is basic, phenolphthalein gives a pink color. On the other hand, when the solution is acidic, it remains colorless. Methyl orange. It is a synthetic indicator used to check out the acidic or basic character of a solution. It is also called a universal indicator. In an acid, it turns reddish color, and in base, it turns yellow in color.